Functions, the complete guide. Covering rational, trigonometric, logarithmic, exponential, and inverse functions. From G Main Unit 7. Essential for Class 11, 12, and G. First, rational functions. A rational function is the ratio of two polynomials, p of x divided by q of x, where q of x is not equal to 0. The domain excludes all values where the denominator becomes 0. Here's the graph of f of x equals 1 over x. Notice the vertical asymptote at x equals 0, where the function is undefined, and the horizontal asymptote at y equals 0 as x goes to infinity. Trigonometric functions. Sine and cosine are the fundamental trig functions. Both have domain all real numbers, range from -1 to 1, and period to pi. Watch the sine wave traced in blue and cosine in red. They are periodic, repeating every 2 pi. Tangent has domain all reals except odd multiples of pi by 2, its range is all real numbers, and period is pi. The unit circle shows how sine is the y-coordinate and cosine is the x-coordinate as the angle sweeps around. The exponential function, f of x equals a to the power x, where a is positive and not equal to 1. The most important case is e to the x, where e is approximately 2.718. Key properties, domain is all real numbers, range is 0 to infinity, it's always positive. It always passes through the point 0, 1. When a is greater than 1, the function increases, shown by e to the x in blue and 2 to the x in green. When a is between 0 and 1, it decreases, shown by 1/2 to the x in red. Notice the exponential growth, it shoots up rapidly. The logarithmic function, f of x equals log base of x. The key relationship, y equals log base of x means a to the power y equals x. Domain is only positive numbers, you cannot take log of 0 or negatives. Range is all real numbers. It always passes through 1, 0. Most importantly, the logarithm is the inverse of the exponential function. Here's ln x in purple and log base 2 of x in green. Notice the vertical asymptote at x equals 0, the curve approaches but never touches it. Inverse functions. If f maps a to b, then f inverse maps b back to a. The composition of f and f inverse in either order gives x back. For an inverse to exist, the function must be bijective, that means both 1, 1 and onto. Here's the most important visual property, the graph of f inverse is the reflection of f about the line y equals x. Watch, e to the x in blue reflects to become ln x in red, they are mirror images about y equals x. Here are the most important inverse function pairs for G. E to the x and natural log. A to the x and log base a, x squared becomes square root, but only when we restrict the domain to non-negative numbers. For trigonometric inverses, sine inverse exists only on -pi by 2 to pi by 2, giving output in -1 to 1. Cosine inverse exists on 0 to pi. And tangent inverse on open interval -pi by 2 to pi by 2. Remember, trig functions need restricted domains to become 1, 1 before their inverse can exist. Key exam tips. For rational functions, always find where the denominator is 0 to determine the domain. E to the x is always positive, ln x is defined only for positive x, inverse exists only for bijective functions. The graph of f inverse is the reflection about y equals x, remember, sine inverse x plus cosine inverse x equals pi by 2. For composite function domains, work from inside out. And exponential growth always dominates polynomial growth as x goes to infinity, crucial for limits. If you found this helpful, like and subscribe for more G and board exam solutions at MAGPIEHUB.